Today we will be going into the field to look at dune succession and formation along the Michigan shoreline. We are in Hofmaster State Park, just south of Muskegon, Michigan. And we are walking along the Homestead Trail. There used to be a homestead probably about 80 years ago here, and there are a few things that tell us that this was a homestead. A little bit farther back, just beyond that post there's a basement hole, and way back, we probably can't see it from here unless we go back there, there is a lilac bush. Now, lilacs are not native to North America, and their pollinator doesn't live here. So the only way that a lilac could be here is if somebody planted it. Now, why would they plant it so far away from the house? Well, usually those lilacs were planted next to outhouses because lilacs smelled nice, and, well, outhouses don't. So they planted it there to kind of mask the odor. This is the forested back dune area. These are all old, very old dunes that have been stabilized by the plants that live on them. So these are a ways away from the lake, but this is typical in these back dune areas. The trees, the canopy trees, are mostly beeches and maples with a few oaks kind of interspersed, but it's called a beech maple forest because the two dominant trees are the beech and the maple, sugar maple. One would think that once these dunes are here, they stay. That's not entirely true. If you look at the ground surface, you see there's a lot of open sand and dirt, and that can wash away in a big storm and cause a gully. But what is even more impressive is what we're coming up on here now. This is the backside of a tall dune that is facing Lake Michigan. We'll see the other side of this dune in a little bit. But the sand is blowing off the face of that open dune, blowing over the top, and is covering over these trees, is burying them. Now you notice that there are a lot of dead trees already on the slope. This is because trees are very sensitive to having a lot of extra soil and whatever on top of their roots. Major mass of the roots in most trees is within 1 to 2 feet of the surface of the ground. So when you start covering a tree up like this, it loses its water, it loses its nutrients, and if you would cut one of these trees and look at its rings or look at a tree core, you would see that the newest rings are getting narrower and narrower as this is being buried. And eventually the trees will die and they fall down. So the big trees, you see all sorts of logs, big trees, that have died and fallen over. And all you see is little trees. That's because these young trees don't know any better, and they start growing on the slope that has been opened up because the canopy is nice and open now, but they won't last very long because the roots are being covered up by the sand. Let's take a look at the other side of this. This right here is the front side of that dune that I showed you before. That little cut in the trees is where all the sand is spilling out and covering up the forest. So let's take a look at these dunes. Of course, we've got the shore, we've got a grassy area just above the shore, and a dune that we start to see trees on up here, and then there's a big bowl behind that dune and an open dune face that is just beginning to get more vegetation on it to help stabilize it. Well beyond that, and then finally forests at the top of the dune. A man named Henry Coles noticed a lot of things happening along the dunes. He saw the dunes being reformed. He noticed that there were lots of things going on. This was right around 1900, and the discipline of ecology was just in its infancy at that time. Ecologists thought that various habitats didn't change very much. And Henry Coles got this brilliant idea that yes, they did change, and they changed with a predictable pattern. And so he started studying the dunes. He did his graduate work at University of Chicago and did his PhD dissertation on the dunes that are now the Indiana Dunes National Park. In fact, there is a little bog in the national park named after him. But let's take a look at what some of the things that he found and some of the things that other people have found since then. First of all, what you see here, this big, long group of different types of habitats succeed one another as you get farther away from shore. And the reason that this succession happens is because of disturbance. Now, disturbance can be in one of two ways. It can be the timing of disturbance. In other words, it can be the disturbance happening almost constantly to disturbance of major storms within 100 years or so. There's the temporal portion of it, but there's also the intensity that makes a difference. So as we are walking along the shore here, we see these waves lapping up on shore. Probably about every 10th to 12th one reaches the top of the wetted zone right here. This kind of disturbance is very mild, but it happens almost constantly. Every few seconds, a new wave washes in. So a plant can't possibly start to grow in this habitat. But if you get just a little bit farther up in this area here where you get dry sand, this probably only gets disturbed every 2 to maybe 3 weeks with fairly larger storms of waves that are 3 feet high or 4, something like that. So there's the possibility of plants growing here. One of the common plants that grows in this area is a relative of the mustard called a sea rocket. One interesting thing about the sea rocket is the shortness of its life cycle. It can sprout and grow and bloom and set seed within 3 weeks. So that by the time the next storm comes along, the seeds are already ripe, the plant has loosened a little bit from the soil, and can be taken somewhere else by the waves and tossed up on another part of the beach where the seeds from that first plant will grow and grow a few more plants. If the plants are tuned to the frequency of disturbance, they can grow here. Now, one thing about what you see here, this is a fairly small beach. And if you look up here, that is definitely eroded away. Now, what has happened here is that over the last 3 years, Lake Michigan has come up about a meter above its normal stage. Usually, the beach was all the way out to where that boat is out there. About 40 to 50 meters. Since the water has come up, it has moved all of that sand out. It has eaten away the foredune that was probably about 10 feet past where the water is now, and it's eating into this first little hind dune where the grass really starts growing. It grows on foredunes too, but it can get washed away. And this hind dune, notice that the roots go quite deep, and the reason that the roots are so deep is because the plants were once down where those roots are. And as the marram grass on top, or dune grass, that grows on top slows the wind down right next to the surface of the dune, and all the sand drops around the bases of those of that grass. The grass keeps on growing up through that newly deposited sand. It just keeps on growing upward. It's perfectly adapted to living in dunes because of that. But it produces this fine network of roots that holds the sand in place, and it isn't just roots. There are also fungi that are associated with the roots called mycorrhizae that are probably 10 times as many mycorrhizae as there are roots, and they invade that sand and hold it in place. Going from the areas that are hit by storms every few weeks, we get to an area that's probably only hit in storms that produce waves of 6 to 8 feet or more. And so this is disturbed only once every 3, 4, 5 years. That is enough so that this dune grass can take hold and start sending runners to hold that sand in place. As it grows up. So it slows the wind down right around the bases of the stems, and the sand is deposited right around the bases of the plants, and the plants keep on growing up so that they don't get covered by the sand. Their roots, though, are still fairly deep, and they still hold the sand and dune in place. Beyond this is an interdunal area. This interdunal area is flat, sometimes kind of dish-shaped, and very often has a pavement of stones. This doesn't happen to have that right now because the sand that was on the seashore has blown up into this interdunal area, so it's covered that stone pavement. Some other plants are starting to grow in here, including this one right here. This is wormwood. And then you finally find the first real tall hind dune behind that with trees on it. The trees that you see, the big ones at least, are cottonwoods, and they are some of the first trees that will inhabit these areas. Anytime there's any kind of a disturbance in these dunes, a break in the vegetation, the wind takes over and starts stripping the dune. This is that same tree dune that I showed you just a minute ago, but it has a path through it, and the disturbance from people, in this case, keeps this from growing any types of vegetation. Dunes in Michigan are not just part of the shoreline, they are also part of the whole western half of the Lower Peninsula. The old dunes that have been forested reach as far into the state as Cadillac and Big Rapids, and all of the ski runs on the west side of the state are on old dunes. So they are a big part of the Michigan landscape. Let's recap what we saw out in the field. I have a drawing here of successional stages or sears of what we saw here, and I want to go through this a little bit. At the bottom we have the wave zone. This is the beach that is constantly wetted by waves that are coming up every few seconds. So you have a frequency of disturbance which is very high, and you have the intensity which is very low. So the disturbance isn't very strong, but it's strong enough to keep any seeds from sprouting and taking root. Just above this, you have the high beach. The high beach only gets disturbed by storms every few weeks, so there's a chance for plants to start growing there if they can time their life cycle so that the entire life cycle happens before the next storm. Behind this is an area that doesn't get nearly as much as far as frequency goes unless you've got a very strong storm, or unless, in the case of what is happening now, you have exceptionally high water. This is the foredune, and this is usually covered with beach grass. Beach grass has the ability to keep on growing upward. The stems and leaves of the beach grass slow the wind down, so as the wind blows off the beach carrying sand, it slows it down around the stems, it drops the sand, and the foredune continues to grow. Meanwhile, the grass is growing upward and doesn't get covered. Just behind this is an interdunal area. I have it pictured as a swale here, which is a shallow pond of sorts, but it doesn't need to be a pond. It can just be a flat area, sometimes covered with a stone pavement because the wind is strong enough to carry the sand away, but it will leave the stones in place. And then behind this is the first hind dune. This is usually completely covered with beach grass, but also woody plants like, for instance, cottonwoods or sand cherries or different kinds of willows. So you've got woody plants as well as the beach grass, and the same kind of thing happens. Any sand that is still there, as it's blowing, it slows down in this area, and the first hind dune keeps growing because of that. Behind this, you'll often find another interdune. This is more likely to have a stone pavement, but it could also be covered with grass. Behind that is the forested dune, and as long as there aren't any really major storms that can topple trees, this can be completely forested. But as soon as a tree is thrown over, it exposes the sand underneath, and that sand starts to be scooped away, and the other trees around it start falling in, and you have what's called a blowout. That is what happened on that dune that is open, and the sand is blowing over the top and covering the back dune forest. There was a blowout that just kept on growing. So this is a forested hind dune. If you look at the disturbance now, the intensity of disturbance is very low at the shoreline, but whenever disturbance occurs farther on, it's usually because of a strong storm, and that intensity of individual disturbance events increases as you go away from the water and eventually kind of levels out. The frequency of disturbance is very often, every few seconds, close to the shore, but rapidly decreases, so that in this mid area here, the frequency of disturbance is fairly low, particularly in the interdune environments. And then, as soon as you get to the forested dune again, the frequency of disturbance would go up a little bit because this part of the forested hind dune is not sheltered by the first dunes, so that this gets the full brunt of any major storms. So the frequency increases. This is typically what you would find in a dune complex next to the Lake Michigan shore. I hope that you have enjoyed and learned a little bit through this video. I'm hoping to put out a few more along the way about the back dunes, because the back dunes are important too. See you next time.